So in this video, we're going to be talking about how to solve logarithmic equations. So you can use the properties of logarithms to solve logarithmic equations like we've been talking about. When solving, remember to check for extraneous solutions because the domain of a logarithmic function does not include all real numbers. So remember, you can only take the logarithm of a number that is greater than 0. So we're going to use this property, the equality property of logarithms, which tells us that if the log base b of x equals the log base b of y, then x equals y. We're also going to use the logarithm properties that we talked about previously. Remember, we can use these properties to combine logarithms whenever the bases are the same. So let's look at some examples. So we're going to use this problem-solving strategy. We're going to start off by using the properties of logarithms to combine the logarithms on one side of the equation. Then we can use the property of equality as long as the bases are equal, and we can solve for a variable. So if we're starting off with the log of x minus the log of 2x minus 1 equals the log of 2. Notice I can combine the terms on the left side using the quotient property. So I'll have the log of x over 2x minus 1 equals the log of 2. So now I can use the equality property because I have the common log at either side of my equation. So that tells me that x over 2x minus 1 equals 2. Well, since I have a fraction here, I can put the 2 over 1, and I can crisscross multiply in order to solve. So on the left, I have 2 times 2x minus 1, and that equals on the right, I have x times 1, which is x. So on the left, I'm going to go ahead and distribute the 2, so I have 2 times 2x, which is 4x, minus 2 times 1, which is 2, and that equals x. So now, to solve this, I'm going to combine all my variables on one side. So I'm going to subtract 4x from both sides. And when I do that, I have 4x minus 4x, so that's going to cancel out. And I have negative 2 equals, remember this is a 1x, so I have 1x minus 4x, which gives me negative 3x. So I have negative 2 equals negative 3x. And so now to solve this equation, I just need to divide both sides by negative 3. So when I divide both sides by negative 3, I'm going to end up with 2 over 3 equals x. Right? Because a negative over a negative is a positive. So remember, you always want to check and plug back in and make sure that you don't end up with any negative numbers that you're trying to take the log of. So this tells me I have the log of 2/3 minus the log of 2 times 2/3 minus 1, and that equals the log of 2. So the log of 2/3 minus the log of 2 times 2/3 is going to be 4/3. 4/3 minus 1, remember 1 is just 3 over 3. So 4/3 minus 3/3 is just 1/3. So that's the log of 2/3 minus the log of 1/3. That equals the log of 2. And if I use the quotient property to combine the left, that tells me that the log of 2/3 divided by 1/3 equals the log of 2, which does in fact check out because 2/3 over 1/3 is equal to 2. So now I can use a similar process to solve this equation for x. So notice the left side I can combine using now the product property. So I can rewrite this as the log of 4 times 1 minus 3x equals the log of 6 plus 2x. So remember on the left side, I'm going to need to distribute that 4. So I have the log of 4 minus 4 times negative 3x is going to be 12x. And that equals a log of 6 plus 2x. So notice on both sides I have the common log. So since both these logs have the same base, I can go ahead and set 4 minus 12x equal to 6 plus 2x and solve. So to solve, I'm going to need to combine all my variables on one side. So I'm going to subtract 2x from both sides. And so that's going to give me 4 minus 14x equals 6. Now to solve, I'm going to go ahead and subtract 4 from both sides. So when I do that, I get negative 14x equals 6 minus 4, which is 2. Now to solve, I'm going to divide both sides by negative 14. So that gives me x equals 2 over negative 14. I can reduce this fraction by dividing both terms by 2. So that's going to give me 1 over negative 7. So I have x equals negative 1 over 7. So now let's try this problem. Let's go ahead and try solving this for x. So notice on the left, there's a few things I can do. I want to combine with the quotient property, but this log has a 2 in front of it. So I'm actually going to use the power property first, and I'm going to move this 2 back up here into the exponent. So this gives me the natural log of x minus the natural log of 3 squared equals the natural log of 3x minus 4. So that means I have the natural log of x minus the natural log of 9 equals the natural log of 3x minus 4. So the left side now I can combine using the quotient property. So I have the natural log of x over 9 equals the natural log of 3x minus 4. So now I have 2 logs with the same base on either side of my equation. So I can go ahead and set x over 9 equal to 3x minus 4. So once again, I have a fraction, so I'm going to set this up as a proportion. And I'm going to crisscross multiply. So on the left side, I have x times 1, which is x. And then on the right side, I have 9 times 3x minus 4. So I'm going to go ahead and I'm going to distribute that 9. So I have x equals 9 times 3x, which is 27x, minus 9 times 4, which is 36. So now we just need to solve this equation for x. So I can do that by subtracting 27x from both sides, so I can gather all my variables together. Remember this x is a 1x, so 1x minus 27x is negative 26x. So I have negative 26x equals negative 36. And now what I need to do is I need to solve for x. So I'm going to divide both sides by negative 26. And when I do that, I get x equals negative 36 over negative 26, which I'm going to now reduce. Notice that both these terms are divisible by 2, and I have a negative over the negative, so those negatives will cancel out. 36 divided by 2 is 18. 26 divided by 2 is 13. So that leaves me with x equals 18 over 13. So now you can pause the video and go ahead and try this example on your own. So in this example, we can combine the left side using the quotient property. So we have log of x plus 6 over x equals log of 2. So we can set x plus 6 over x equal to 2. And then we can cross multiply. So we have 2x equals x plus 6. Subtract x from both sides to solve, and you get x equals 6. If we plug it back in, we can see that this is a good solution, so x equals 6 does work. So remember, you can use the properties of logarithms to help solve logarithmic equations.